All right, so on here, we're continuing the notes from yesterday. I had already drawn out all the graphs and, again, posted that to Edsby. Hopefully you got those. If not, again, you can copy the graphs as we go along. But we had two things to finish up. Writing an equation from a graph, and then also we needed to be able to graph an inequality. So the 6 examples that we have up here are graphs that, if these were given to us, we could then go and find our actual equation. So yesterday I had said that if you have a graph where you can clearly identify the y-intercept, like on this graph, then it's going to be easier to use slope-intercept form. Remember, slope-intercept form is y equals mx plus b. So that was the format that we wrote this one in. On this graph, however, we can't clearly identify a y-intercept because it's going through the y-axis there. It's not at a point where two of the grid lines meet. So for something like this, we could write it in the format of point slope form. Y minus y1 equals m times x minus x1. Now, in order to write something in that format, we need our slope. So again, we have to identify our slope. So here we go, from this point, we go down 2 units, so that'd be -2. And then we go over 5. So we can identify our slope as -2 over 5. He's not here. He might be late. He is a lot of times. And then give me 1 minute. I'll send him. Okay. So on this one, we have our slope is -2 over 5. But now you need one other piece of information in order to write your equation. So we need to know a point. Well, we have 2 different points to choose from. So I could take this point and write an equation using that point. And if I did that, we'd have, again, plug it into this format, y minus the y value, which would be 1, is equal to m, which is our slope. Whoops. So 2 over 5 times x minus x1, which is the x value of our point. So since this is -2, when we plug it in, it's going to change this because the original sign is a negative. So it now becomes +2. And that would be an acceptable equation. But that's not the only equation that would work. We could also use that point down there. If we use this point, our equation will be slightly different. We'd have y minus, this time the y1 is -1, so +1, equals -2/5. Oh, I forgot my negative in the first equation, I just realized. Negative. And then we have x minus, this time we had a +3, so x minus 3. Now, those 2 equations look very different, but they're both correct. If you wanted to check to see if they were the same, you could take both those equations, change them to slope-intercept form by solving for y. So in order to do that, you'd have to distribute your slope, and then move that one value over to the other side, and you would have the same exact equation. So there is a possibility of having more than one equation as a correct answer. Now, for your test, you will have all multiple choice. So if you get an equation that's not on the multiple choice, check to see if there's another point you could use. Or if it's in slope-intercept form, change it around so that it's in slope-intercept form. Solve for y. So again, just because your answer choice doesn't appear doesn't mean you weren't correct. You might want to look for another scenario. All right. Number 3.
Teachers and student part this interruption. Teachers, if you have any students with testing pass, they must be released at this time so they can report to room 338 or 341. Once again, any students with a testing pass must be released at this time so they can report to room 338 and 341.
Yeah. All right. What type of line do we have in number 3?
Zero slope.
Straight how though?
Huh?
So specifically, what type of line is it? So that has a very specific type of slope. Zero. Right? All right, guys, give me 1 second to write this fast. There you go. All right. So on number 3, we have a horizontal line. Since it's a horizontal line, we should know automatically that we have a slope of 0. So, slope is 0. Can we easily identify our y-intercept? Yeah. What is our y-intercept? It's at 1. So, we have a slope of 0, a y-intercept of 1. So we can easily write this in slope-intercept form. What would our equation be if we write this in slope-intercept form? Y equals 0x plus 1. Now, do I need 0 times x there? No, because what happens if you have 0 times any value? It's just 0, so that cancels off. So our actual equation here is just y equals positive 1. Anytime we have a horizontal line, our equation for a horizontal line will just be set equal to the y value that goes through that y-axis on. Again, if it's a horizontal line, it will have to pass through the y-axis. Whereas if it's a vertical line, so actually let's skip down to 5 for just a second. On number 5, it's a vertical line. What's our equation going to be set equal to? Is it going to be in like slope-intercept form or point-slope form? No. Because remember, our slope here is undefined. So we can't write this as one of those two equations because we don't have a slope to plug in. For these, this vertical line passes through which axis? It passes through the x-axis. And at what point does this pass through the x-axis? 3. So our equation on this one is just going to be x equals 3. And that will be our final equation. So again, for a horizontal line, you're going to end up with an equation which is just set equal to y. A vertical line is just going to be an equation set equal to x. All right. Now, I usually also teach this, so let me write this here. Some math teachers come up with different sayings for different things. I don't even remember who told me this one time, but it's just an easy way to remember properties of horizontal and vertical lines. Horizontal lines have a 0 slope and are set equal to y. Vertical lines have an undefined slope and are equal to x. Hoi vux. Just something simple that you can memorize. So horizontal, 0 slope, equal to y. Vertical line, undefined slope, equal to x. And that's what that represents. All right. On number 4. So, on this one, what format should I write this line in? Should it be slope-intercept or point-slope? For number 4. So can you easily identify a point that it's going through on the y-intercept? You said yeah. All right. So since we can identify a y-intercept, which version am I going to write this in? Okay. You can write it in y-intercept form because you just have to identify the slope and the y-intercept. Again, so it's going to be easier. Could you write this in point-slope form? So like if they ask you, write an equation for this in point-slope form. Yeah, you just have to know the slope and a point. So, hold on. Now look. Good morning. Okay. He is not here yet. Raul. Alright. Yeah, I do have him right now. Yeah. So no. Okay. Alright, can do. Alright, bye. Okay. Sorry. Give me a second. If you want to go ahead and go down there, 341, they want you for testing. Alright. And then number 4. Alright, so again, writing this in slope-intercept form, that would be the easiest thing to do. So our slope, going from here up, whoops, I went a little too far, up, and then over. We're going up 2, over 1, 2, 3, 4. So our slope is going to be up 2 over 4. We could also reduce that to be what? 2 over 4 reduces, right? 1/2. 1/2. And then for our b value, where's it crossing the y-axis? Where's it crossing the y-axis? The y-axis? This is our y, right?
Oh.
Where's the line cross the y?
1.
No.
Doesn't?
It's crossing at
0.
0, right? It's crossing at the origin. So it's crossing at 0. So for our equation here, y equals mx plus b 1/2 x plus 0. Do we need to put the 0? No. So if it's crossing at the origin, we could just write it like that. We don't have to have the y-intercept. Alright. Last one like this, and then we have to do a little bit with inequalities. And number 6, we have slope. It's going to be, we're going down 1 and over 1, 2, 3. Our y-intercept. Well, do we see the y-intercept on this one? Is it easy to identify? No. So we're not going to use y-intercept. So that means that we have to use point-slope form. So let's go ahead and use this point first. So we could say y minus y1, which was 1, equals the slope, negative 1/3, times x minus negative 1, so plus 1. If I use the other point here, we have y minus 0 is equal to negative 1/3 times x minus 2. Now, for the second one, I could actually reduce that a little bit, because do I have to write minus 0? No, so I could also leave the 0 off, and just write it like this. And that would still be fine. All right. Last thing. All right. We're going to do 2 quick graphs here. So, inequalities. If you have a less than or equal to sign, sorry, less than or greater than sign, I said that wrong, then your lines on your graph will be dotted. If you have a greater than or equal to or less than or equal to sign, your lines will be solid. And then you will always have to shade. So if you have a greater than or greater than or equal to, shade above. If you have a less than or less than or equal to, shade below. Yeah, there you go. So those are the basics that we need for graphing inequality. Everything else is the same. So if I gave you an equation, and I'm only going to give these to you in slope-intercept form, y is greater than or equal to 2x minus 1. Y is less than negative 1/2 plus 2. Don't need a huge graph for these. Try to keep them small. On this first one, graphing it is the same as what we did previously. We have a -1 for our y-intercept, and we have a slope of 2. So we're going to graph it by first finding that y-intercept at -1, and then we're going to do our slope of 2 up 2 over 1. And since we have the and equal to here, it's going to be solid or dashed. Solid. So if it has and equal to, that means the line is included, and it's going to be solid. Just like when we have the and equal to, we have a closed circle. Here we represent it as a solid line. The other part is we need a shade. So we have y is greater than. For any time we have a greater than symbol, y being greater than, think about the y-axis, it goes up and down, right? So if y is greater than, we're going to shade everything above, because those would be the values that are greater than for y. So we can shade everything above. The other way that you could determine shading is by picking a point and seeing if it works. So, for example, if I picked a point 0, 0, you could plug in 0, 0 and see if it comes out to a true statement. If that works, you shade on the same side of the point that you plugged in. If it doesn't work, you shade on the opposite side. Yeah, that's another way of doing it. For number 8, so we have, again, our b value is what? It's 2. Our slope, -1/2. So, up at 2, you're going to do a point. Our slope down 1 over 2. Should I have a dotted or solid line connecting those? Dotted, because it does not have the and equal to this time. So it's going to be dotted, or you could say dashed, either way. And then we still have to do shading. So it's a less than symbol. So we're going to shade above or below that line? Below. So y is less than, we shade below. And that's it. Those are the only little things that are different when you talk about inequality. Now, on the paper that I already passed out to you, I included more inequality graphs probably than anything else on the back. All right. So I included probably the most stuff. The last part of the worksheet is what we did today. The rest of it is review over everything else. I will work on an answer key during the day today, and I will post it online so that you can look at it, because again, tomorrow we're supposed to have our next test. I will take a few minutes at the beginning of class to answer questions if you have any, but again, I'll post the video so that hopefully you can get most of the questions out of the way first. The test itself is, I think it was only 14 questions, I think is what it ended up being. So again, it's not very long. I'm only asking 1 or 2 questions from each thing. But again, go online tonight, check your answers, all right? Watch the video, and double check your work. But again, I'll use the first couple minutes of class tomorrow to see if you have any other questions before we start the test, all right?